Next, we'll be talking about your Brownian motion experiment, which is actually a experiment that will actually tell you or actually show you how we can actually show or prove that kinetic particle theory of matter, kinetic particle model of matter exists. Like we are talking about the random motion, right? So this evidence itself is talking about your conclusion. So how can we conclude that yes, my particles are in constant random motion itself? Basically, we have this observation. So smoke particles, not the air or the water, smoke particles are in haphazard manner. This manner itself is what we call real Brownian motion. So the thing is, we can conclude from this observation. So we see that smoke particles are moving in this weird constant random motion, in this weird haphazard motion, this weird disco kind of pattern itself. So something like this. So you can see all the small little specks of white dots that you see here, right? Those are all your smoke particles. And you can see that they're all kind of jiggling about in all sorts of random direction. You can just focus on one of them and you realize that they don't always move in the same direction. They don't like continuously move in one direction. They will actually continuously change direction and jiggle big and bits like in the disco party kind of style, right? This weird motion that you see is what we call your Brownian motion. So what can we conclude from this observation itself is that number one, firstly, smoke particles are much bigger than your air particles. So the thing is, even though yes, according to your kinetic particle theory, my smoke particles themselves, they will be moving in continuous random motion, right? However, the much more exaggerated and much more faster change in direction itself indicates that there must be some other things that's causing it to change direction all the time. So the thing is, why you have this haphazard Brownian motion itself must be because my air particles are bumping, colliding with them to change their direction itself. So smoke particles are the more modernized version itself, but in the past where microscopes aren't as detailed, they actually use pollen grains in water itself, and you can actually observe the same phenomena, same observation, keyword observation that you have. So the keyword is number one, what is Brownian motion itself? Okay, so what is Brownian motion? Explain why you have Brownian motion. Okay, number one, Brownian motion is the motion or the random motion of your visible particles itself, and what they caused by, they're caused by the random collisions with your air and water molecules itself. Now on the other hand, why do we have this? It's because your visible particles are collided by your invisible water molecules that are in constant random motion. So because each and every one of them collides with them, they actually change direction. So next one is, how can we prove? Okay, so from the Brownian motion observed, the air molecules or air particles must be moving in, okay, from the, rather than Brownian motion, is rather than from the sudden changes in direction of the visible smoke particles, it can be concluded that the air molecules must be moving in random directions and therefore colliding with the smoke particles to change direction. The continuous motion of the smoke particles indicate that the air particles colliding with with it must be in constant motion. So basically, if you want to work backwards, why do I have Brownian motion? Or first thing, what can you conclude about your air particles? Because from what I see that your visible smoke particles, the big one, right, is moving in constant and random haphazard motion itself. So because of that haphazard motion itself, I can say that my air molecules that is colliding with this bigger visible smoke particle must all be moving in random directions, because if all the air particles are in the same direction itself, by right, my smoke particles, when they bump into the air particles, or when the air particles bump into the smoke particles must all move in a specific direction. But this is not the case. I am moving in random directions, which means the collisions must also be in random directions. And if you notice the constant changes or constant collisions itself, I'm not just like bump one time and that's it. One occasion, done. No. I'm being bumped into it continuously, non-stop, all throughout the observation. When I see, you can see that the particles themselves, when you actually collide with them, it's not like a one-time thing, it's all the time, throughout the entire journey. The person who is looking through the microscope, he's not moving the microscope itself, except sometimes when he's moving a spotlight. But you can see even when he's not moving it, the particles are continuously changing direction, jumping around, moving around. You can see that that is actually caused by the continuous, constant, random motion of the air particles itself, and therefore this can prove that kinetic particle model of metal is true, because from the observation I see, I can conclude backwards. Because for you to move in such a manner, I must be colliding with particles that are in constant random motion. Okay? So, next page. Now, barrel of bad news. You need to know how to draw the setup, because there are described experiment questions where they need you to draw this out and show them how to label it. Okay, so how can you describe and explain the smoke particles? The smoke particles are moving in a haphazard or random and continuous motion. Explain why. Because due to the collisions by invisible air particles that are in constant random motion. Let me just bring this in. So on top is my describe, below is my reason. So this is it. So when you want to draw this air particles itself, let's say we have one here. Very straightforward. You can literally just drop your pen and pencil and see what direction it points to. Don't be standard. So randomly I can draw like this. I can draw like this, like this, like this, like this, like this, like this. Totally random. Don't have a pattern. Okay? Like this. So the thing is, if you don't draw it as if you're bouncing off the wall, just randomly draw it. Don't have a fixed pattern. Don't draw regular shapes like triangle, rectangle, circles. Just be totally random. Think of it as you just tikam and you just drop your pen and pencil, and what direction does it point to, literally. Okay, don't need to draw too many, about 5 to 8 direction changes itself is perfectly fine. Don't draw it when it bounces as if it's bouncing off the walls of the container. Don't do that. Be as random as you can, as weirdly as you can. Try not to have a pattern. Okay?